Question 4. T is 100 kilometers due west of Q. T is west of Q. T is traveling 10 kilometers an hour in a direction 30 degrees south of east. South of east is this way. So that's positive, negative. So let's look at the velocity of T first. Velocity of T is equal to 10 by the cos of the angle, by the cos of 30 in the I direction. And we have a negative 10 by the sine of 30 in the J direction. So I should put my T in. Velocity of T, 10 cos of 30 is root 3 over 2. So that's going to give me 5 root 3 in the I direction. And the sine of 30 is a half, so that's going to give me minus 5 in the J direction. That's the velocity of T. The velocity of Q, northwest. The velocity of Q, let me check that, 20 kilometers an hour in a northwest direction. So Q is going in this direction. The velocity of Q, northwest, is 45 degrees. We get 30 here. So the velocity Q, 20 by the cos of 45. So what are we saying here? Positive, no, negative, positive for Q. Negative, positive. So we have minus 20 by the cos of 45 in the I direction, plus 20 sine 45 in the J direction, and that's going to be minus 10 by 1 over root 2, minus 10 over root 2. Why did I write J there? In the I direction. And then plus 10 over root 2 in the J direction. That's the velocity of Q. I'm using T speeds, minus 20. And root 2 is also 1 over root 2 is root 2 over 2. So this can be written, can't it? This can be written as minus 10 root 2 in the I direction, plus 10 root 2 in the J direction, just to tidy it up a little bit. So then we're asked for the velocity of T relative to Q. Let's move up slightly. The velocity of T relative to Q is the velocity of T minus the velocity of Q, which is 5 root 3 in the I direction, minus 5 in the J direction, minus 10 root 2 in the I direction, plus 10 root 2 in the J direction. And that's going to give me 5 root 3 minus 7. So I'm going to decimalize this. I can't see how we could not decimalize. So it's going to be 5 root 3 plus 10 root 2. That gives me 22. I'll keep the, is it 0.8? Oh, 2.8 in the I direction. And then minus 5J minus 10 root 2 is going to give me minus, that's 19.2 decimals 1.4 in the J direction. The velocity of T relative to Q. Part 2, the magnitude and direction of this. So the magnitude of T relative to Q is the square root of 22.8 to be squared plus 19.14 to be squared. We deal in kilometers and meters here, kilometers an hour. So that's going to give me 29.77 kilometers an hour. And the direction, theta, is equal to the inverse tan of 19.14 over 22.8, which is 40.0125. So I'll just leave it at 40.01. I'll just leave it at 40 degrees. And what direction is that? Positive, negative. Positive, negative is down here. So that's going to be 40 degrees in the direction south of east. And then we're looking for the shortest distance. Just jot down T and Q again. T and Q. t relative to q was positive negative, so positive negative is in this direction. Shortest distance along here, we call it x, and what was the distance between t and q? 100 kilometers. 100 kilometers, and we have theta here is 40 degrees, so you can say that the sine of theta is equal to O, put in your right angle, over h, so 100 by the sine of theta, the sine of 40, is equal to the shortest distance. So the shortest distance in this case, 100 sine 40, is 64.3 kilometers. Question 5. Two straight roads cross at right angles at O. X is running towards O at 7 meters a second, and Y is cycling on the other road at 24 meters per second. And we're given this diagram and told that when X is 100 meters from O, Y is at O. Find the velocity of X relative to Y and the shortest distance. Well, let's look at the velocity of X here. It's just going in the positive I direction, so it's going to be equal to 7I plus 0J. And Y, the velocity of Y is just positive J direction, so it's going to be equal to 0Y plus, what is it, 24J. So the velocity of X relative to Y is the velocity of X minus the velocity of Y, which you can see in this case is just going to be 7I minus 24J, the velocity of X relative to Y. So we have our diagram. Take it out here. We have 100, we have X, we have Y, and we have 7 minus 24. So positive minus is in this direction. The velocity of X relative to Y. Shortest distance here. Well, I should probably call it something else other than X in this case. Let's call it S for distance, or D. We have our angle here, theta. We can say that the tan of theta is 24/7. Now this is a triangle that does work out evenly. 24/7. 24 squared is 576, and plus 49 is 625. So the hypotenuse here will be 25. So the sine of theta is 24/25. So we can shorten it down and say that 25 sine theta is equal to, well, let's not shorten it down. Let's say the sine of theta is equal to O, which in this case we're calling it S, over H. Put in your right angle, 100. So 100 sine theta is equal to my distance. So off to the left here, 100 by 24/25 is the same as 4 by 24, which is 96 meters, is equal to S, or whatever you called your shortest distance. Question 6. P 350 kilometers due east of Q. Velocity of P is minus I plus J in kilometers an hour, and the velocity of Q is 3I minus 2J. Find firstly the velocity of Q relative to P. So the velocity of Q minus the velocity of P is equal to 3I minus 2J minus I plus J. That's going to be 3I minus I, 2I minus 2J minus J minus 3J. Obviously not 2I, 3I minus I, just be careful, 4I. 3 plus 1, 4, and just double check, minus 3, 4I minus 3J. We're asked for the magnitude and direction. Well, the magnitude of the velocity of Q relative to P is going to be, you can see it's going to be 5 here, 4 squared plus 3 squared, which is 5 kilometers an hour. Theta, the direction, is equal to the inverse tan of 3/4, and the inverse tan of 3/4 is that 36.87 degrees. Yeah, 36.87 degrees. Because this works out evenly, let's just put it into a diagram. Opposite over adjacent hypotenuse. Sine theta, which we'll need for shortest distance, is 3/5. So the shortest distance is number 3, the shortest distance. So when we do a little diagram, P is east of Q, so we have P east of Q, and 4 minus 3, positive negative, is going down in this direction. So that's the velocity of Q relative to P, and they are 350 apart. Theta in here. So we're looking for x, the shortest distance. The sine of theta is equal to x over 350. So 350 sine theta by 3 over 5 is 73, which is 210 meters. Is the shortest distance. And how long will they be within 290 kilometers of each other? Well, I'll do another diagram for that. So just sketch it here. So 290, we imagine this is 290. And down here is 290. We need to get this distance along here. So I just take one of those right angle triangles out where the hypotenuse is 290. And the straight side x, the shortest distance, is 210. We can find x here, the square root of 290 squared minus 210 squared, and then we'll double it. So that's going to be 290 squared minus 210 squared. It works out evenly, I think, to be 200. It does, so that's 200 kilometers. By 2 is 400 kilometers, and these questions are always asked how long. So what was the relative speed? It was 5, wasn't it? It was 5. So we have the relative speed, the relative distance over the relative speed, is going to be 400 divided by 5, which in this case is in hours. It's going to be 80 hours. Question 7a is 300 meters due west of B. The velocity of A, velocity of B, find the velocity of A relative to B. So the velocity of A relative to B, the velocity of A minus the velocity of B, which is equal to 2I minus J minus 2I plus 2J. So that's going to be equal to 2I plus 2I, which is 4I, and minus J minus 2J minus 3J, another 4 and 3, the velocity of A relative to B. The shortest distance, well, we can say here, I'll do a diagram, but we can say that the tan of theta is 3 over 4. So the sine of theta, I know you can see what it is, but always do your diagram just to eliminate those basic errors that can be made. O over H, 3 over 5. So we have A west of B. Here's my diagram. A is west of B. A is west of B. 4I minus 3J is positive negative down in this direction. The velocity of A relative to B. The shortest distance is somewhere here. This is my theta, this is my right angle, and this is my shortest distance, x. So the sine of theta is equal to x over the 300 meters that they were apart. So 300 by 3 over 5 is 63, so x is equal to 180 meters. So it's my 180. And the length of time they remain in vision, if visibility is 225 meters. So this is 225 meters from here. And this is 225 meters from here. So we're looking at this right angle triangle. And we're going to double it to get x. So I'll put my x on the bottom this time. We got the shortest distance to be 180. This is now 225. So x is going to be the square root of 225 squared minus 180 squared. That works out to be 135. So by 2, is 270. That's 135. 135. And the relative speed here, it's going along for 270 meters. And did we get the relative speed? We didn't. The magnitude of A relative to B. You can see it's going to be 5, excuse the burps, 4 squared plus 3 squared, which is 5 meters per second. So we're going to have, what do we have, 270? 270 over 5 is going to be 54 seconds, which is what they asked us to find the relative, the length of time they remain in vision is this 54 seconds. 27 in this section. 27 in this section. That's this question. On to the next video.